right, this video is going to talk about how to write the equations of a linear line using slope-intercept form. So to start off with, first of all, let's review real quick what slope-intercept form is. Again, we've got a slope-intercept form equation right here. Basically, remember that that's y equals mx, so a number times x, plus b. And m is going to be our slope. So again, if we're looking at our equation, our number that's multiplied by x is -2. So again, that's going to be our slope, m equals -2 very simply, or -2/1 if we think of that. And then b, again, is what's added on. B is going to be our y-intercept. And again, I'm looking at our table of values down here. Our y-intercept is always where x equals 0. And notice that that 3 right off the end, again, if x was 0, -2 times 0 is 0, plus 3 is 3. And we get that point right on the y-axis, 0, 3. So again, the easiest possible way to graph an equation, as you'll notice over here on the graph, is to start from the y-intercept, right? Somewhere to start. And then we need the slope to tell us where to go. Well, remember that that's always rise over run. So we can just say that that's -2, so down 2 units, and to the right 1 unit. And again, that's where we get that point, 1, 1. So you'll notice that point, again, over here on our table. And again, we don't necessarily need the table from those points. I can go down another 2 units and over 1, down another 2 units and over 1, and I can get lots of points very quick and simple, right? Start from the y-intercept, follow the slope to get more points. But really, those two aspects will define that line. Knowing the slope and the intercept, I can write an equation. Well, that's the major idea behind this section, writing linear equations in slope-intercept form, in y equals mx plus b form. So let's do 3 quick examples here, and then we'll show you a few more more technical examples. So on the left here, they say, let's write an equation of a line. So again, any form would work. There are other forms, but let's stick with slope-intercept form of equation of a line when the slope is -2 and the y-intercept is 5. Well, if we know m and we know b, all we literally have to do is write y equals -2, right, what used to be m, times x plus b. And we've got our equation of a line, again, that would have a slope of -2 multiplied by x plus 5 plus that y-intercept. Now, they won't always word it that way. They won't always literally say it's the y-intercept. Notice over here at the right, write an equation of a line, right, whose slope, again, is m equals 3/4, so they're handing us the slope, and goes through the point 0, -4. Well, now remember what we said on the first screen. If x equals 0, that makes this, right, my y-intercept, which means now again I can say y equals the slope, or 3/4. Always a good idea to write it top to bottom, right? Don't like that slashy fraction in the statement, but it is what it is. But 3/4 x plus -4, or basically -4, right? Same thing as plus -4. And I've got my equation with a slope of 3/4. And I guarantee you, if you plugged 0 in for x, right, 0 times 3/4 would have been 0, -4 would be -4. So plugging in 0 will get us -4. Our y-intercept would have been -4. Finally, down here at the bottom, write an equation of a line shown in the graph. Well, remember, kind of like the steps are saying at the left, first we need to identify the slope, kind of like we did in both of these previous problems, then identify the y-intercept, and then finally we can write our equation. So let's go ahead and write down m equals and b equals. Well, b is probably easier to spot. If we take a good look at our graph, looks like we're counting by ones here. So it looks like we went down 1, 2, 3, 4. My b is going to be -4. And my slope, well, why don't I just count from point to point? How about we go through this point 2, 0 here? And it looks like we went through the point 3, 2 here. So we went up 2 and right 1. Rise over run, well, that's 2 over 1 is 2. So y equals my slope of 2 times x, any x value on my graph, -4, right, plus -4. And that should be the equation, right, starting from -4, going up 2, right 1, up 2, right 1, and plotting all the points, right, on our line. If we know the slope and the intercept, we can write the equation. Well, let's look at a couple of slightly differently worded problems here. On the left, we just have it in function form. So the first thing I would remind you of is function form is just another way to write coordinates. So f of -2 equals 6 is really saying input -2, output 6. F of 0 equals -4 is the input of 0 and output of -4. And we sure have had a lot of y-intercepts in these examples that were -4, haven't we? When x is 0, y is -4, or basically that's our b value. Now the one thing they didn't give me was the slope. But remember, we know how to find that. Remember that m equals y minus y, so why don't we do -4 minus 6 divided by 0 minus -2, so that's going to be a plus 2, makes -10 over 2, and -10 divided by 2 would be -5. So now I can say y equals my slope times x, and again b is -4, so plus -4 or -4, and I've got an equation that should work. Now I do want to be careful because notice the initial problem was f of 0, f of -2. So instead of saying y, why don't we be specific here? This is f of x, right? It's a function of x, -5x minus 4. Finally, notice the big problem over here at the right. In 1990, California had a population of about 29.76 million. During the next 15 years, the population was going to increase by an average of about 0.31 million people per year. Write an equation to approximate the population of California in any year from 1990 to 2005, but let t equals 0 represent 1990. Now, all those words are telling us something very important. Again, t equals 0 is times 0. If we think about a graph, right, times 0 is going to be where we started from, right? Which means that's my initial value. That's my y-intercept. T equals 0 is kind of like saying x equals 0, right? When that initial value is 0. So when we plug in 0, we're going to get the population in 1990. Well, didn't they hand us that up top here? That makes this my y-intercept. So again, we've got a coordinate point, most definitely at 0, 29.76. And notice in that last statement, average of about 0.31 million people per year. People per year is telling me as the years go up, the people go up. Well, that sounds a lot like a slope. So this is going to be my m value here. So what we can actually say is the population, right, well, let's just call it p, will equal 0.31 times t, right, whichever year we're in, plus 29.76, right, that y-intercept value, right, for us right there. And very simply, if we want to predict 2005, all we have to say is that p will equal 0.31 times 2005. Now that's 15 years after 1990, right? Isn't that 15 years later? So let's plug in 15 plus 29.76. And now all we have to do is find that number. So let's go ahead and open up our calculator real quick here. I'm going to clear off what's on the screen. And all we have to do is type in, again, 0.31 times 15 plus 29.76. Looks like 34.41. So P, the population, will equal 34.41, again, million people. I hope that helps you with writing slope-intercept form equations. Remember the major steps. If you can identify the slope and identify the intercept, you can very simply write a y equals mx plus b, y equals the slope times x plus b equation. If you have any questions, talk to your teacher. Otherwise, have a great day.